Okay,
Great.
okay. Um, Makani, so you can introduce yourself, right? So I'll just give
Yes.
you the floor. Okay.
Okay, cool. So here we are. Today we're going to talk a little bit about Astronomer and how that can help us sort of manage our airflow, manage deployments, and all this good stuff, which we will get into. So I'll start with just a quick introduction. So my name is Makani Cartwright. I am a data scientist and engineer at Veretto currently. So doing the startup thing, which is a great ride. Highly recommend. And I'm really sort of involved in all things data there. So working on getting our predictive modeling up. Mostly doing BI work and pipelining and sort of moved in that data engineering direction, which is really, that's the focus of this conversation, is really how do we enable production grades, data pipelining and data workflows. So let's dive in. What we're going to be talking about really is Astronomer, right? And Astronomer is a company which is tied to Airflow. And so the history of one is the history of the other. So in 2008, Brian Chesky, Joe Gebbia, and Nathan Blicharczyk, I'm going to butcher that name, Blicharczyk, they founded Airbnb. And by 2015, the sort of quantity of data that they had to deal with had gotten much larger than the tools that they had at the time were ready to handle. So they began the Airflow project. That went through a few iterations, right? And eventually, well, in 2016, they joined the Apache Foundation Incubator. 2018, they graduated. Sorry, 2019 they graduated that program, becoming a full-fledged Apache project. And during the same time, right, Astronomer was founded, so in 2015. And then it was initially a sort of data routing tool. And then they pivoted in 2018 to focus exclusively on the Airflow product. So in 2020, Airflow 2.0 is released. Very shortly thereafter, Astronomer was moved over to Airflow 2.0 as well. As of now, Astronomer employs 16 of the 47 Airflow contributors and 7 of their PMC members. So those are the primary Apache folks who are controlling the project. And so the Astronomer platform and the Airflow platform are intimately tied together, meaning that the Astronomer will be up to the latest and greatest that Airflow has to offer more quickly than its competitors, right? So the Google and Amazon offerings will be a little bit behind on the releases just because they're not, so intimately tied to the product. Cool. So that's all well and good, but what does it do, right? So Chris had a great presentation on just Airflow, right? Really diving into what are all the components and how does it all work. So if for a deeper dive, go check that one out. But a just broad recap, right, is it's a tool to orchestrate your data pipelines, right, and make sure everything is timed and scheduled properly. Make sure that you have retry logic and all this good stuff. So the key focus is, right, of Airflow and what it's enabling is flexibility, first of all, right? So making sure that everything is just a self-contained step, which can be, combined with any sort of other steps in DAG. These are extensible, right? So they connect well with any other sort of open source tools, with data sources, with AWS, Google Cloud. It's a very straightforward connection with any of those. Scalable, so it's built on really 2 technologies. One option is the Celery Worker technology, and the other is the Kubernetes. And so Kubernetes really allows this platform to auto scale, so you don't have to do so much manual management of that, right? Rerunnable. So this is something that's just amazing about the Airflow project, is you can say, I want to rerun a particular pipeline, right, from the middle onward and take the state that it was previously, which is just makes all sort of debugging and rerunning fantastically simple. And then the whole thing is open source, right, which is always a great thing. So high level, that's what Airflow is and what it was designed to do. And then let's talk a little bit about, how you can really leverage this. So in order to get it up and running, it's actually very simple to get it started, right, for sort of a proof of concept type platform. But in order to make it production ready, it's not a trivial process, right? There's a lot of moving pieces to Airflow and a lot of additional components which need to be managed by like a DevOps team, right? And so it's um, it's a lot of work to get it up and running. And it's a lot of maintenance to make sure that it goes smoothly, which, huge kudos to all the DevOps folks out there who drive this stuff. Um, Airflow itself requires these four components: the web server, so the web server, which is how you interact with the product; the scheduler, which really determines, when are things being kicked off and what are the interactions between those; the executor, which actually drives these tasks, right, and runs them through; and then there's metadata database, right, so storing all of your DAGs, storing all of your metadata information. And all of those for a scalable system need to be sort of set up separately. Um, Airflow out of the box will spin them up with, a small local version, so the database is like SQLite, but in a production environment, you quickly graduate beyond that and need to have, RDS and all of these other components which require management of their own. Some other things that Airflow doesn't do out of the box, right, is security management, access, anything along those lines, logging. It will log within the platform, right, but you can't collect those logs and monitor the sort of deployments as a whole. Um, and then there's also, I don't have it on this list, but the deployment piece, right, is a big draw of the managed platform so that you can automatically integrate this with your CI/CD. Um, Airflow, in order to set it up to scale, right, you have to go the Kubernetes route, and you have to make sure that you are, fully managing that process as well. So it all sort of comes together to say that it is a wonderful product that takes quite a bit of maintenance in a production environment. So that's the problem that Astronomer tries to solve. So they're a managed service for workflow, interacts with all three of the big three, so Google, Amazon, and Azure. Um, and it handles all of those things I just went through, right? So managing your environments, managing your deployments, all of your permissions, all of your monitoring, all that stuff is going to be handled as part of this platform. So, and then the other main piece here is that it's really driven by the Airflow contributors, so it will stay ahead of those other competitors. Um, I'm gonna stop here, take a quick pause. Does anyone have questions so far before we dive into sort of Astronomer itself? No, cool. Let me just keep chugging along. So, at a high level, right, and this is coming from their sort of promotionary materials. Um, this is how they're architecting their system. So they have a control plane, which is how you interact with all of these components, right? So you're managing your environments, your deployments, your permissions, and any sort of monitoring. That's all living on this control plane, which is really managed entirely by Astronomer. That is built on top of Airflow, which is running in your own system. So, for example, we have it on AWS, and so there's a specific cluster, which is running Airflow, and then there's a single Astronomer user, which has access to that cluster and then provides access through the SSO integration. That then will interact with all of your external systems using, the typical routes. So for our system, we have AWS and we need to connect to RDS and we need to send things out to S3. So that's all being managed just using the REST APIs available. So that is this. Now I'm going to go into a little bit of the features, right, in a little bit more depth and talk about how they enable these things, right, that they claim to. So security is really a big one, and managing permissions, it takes a lot of DevOps time. So what they've done is said, we're going to have a single tenant, right, in this Airflow environment, and that is going to be the Astronomer user. So that's the only user which has access to the Airflow instance. And then for you to interact with Airflow, you interact through this single tenant. So you log on using their SSO, and then you have full access to any particular deployment. But it's all managed through a single Astronomer tenant in the client's environment, right? So we have our own Amazon cluster, right, which is running all of this, and Astronomer just has a user which has access to that. There's also role-based access to that, so we can grant, for example, our growth team, right? We have folks who just manage, did customers' data run through properly, and they have view access. They can see, did the pipelines run through successfully, but they can't modify anything, which is a nice feature to provide visibility to the rest of your org. And then, yeah, single sign-on, right? So making sure that those who have access as you have intended. Cool.
Makani, sorry, can you
Yes.
return to the previous slide? Uh, sorry again, I'm confused. In role-based access, you says that there are multiple users with different access, but in the single tenant, you say only one user. So
Yes. Yeah. Let me explain that a little better, perhaps. So there is only a single Amazon user which has access to Airflow, and that is the Astronomer user. So all interactions with Airflow need to go through that user. The um, Astronomer platform then allows you to log in and make changes as a user of the Astronomer platform, right? So you need to make changes using that control plane, and then that control plane is the only thing which actually interacts with the system. Um, does that does that make sense?
yes, now it does. So we have single AWS user and we have multiple Astronomer users.
Right, exactly. And those Astronomer users can be configured to be view only or editor, right? But it's all going through that single AWS user.
Okay, thank you.
Cool. So deployments is huge, right? This is one of the biggest benefits that we've seen is just being able to automate our entire deployment process and across multiple environments. So within Airflow, it's very easy to spin up a new environment completely isolated from others, and then also to deploy an existing environment into another, which is a pretty common use case as you sort of promote things from a staging environment to production. So very simple to spin up an environment, and they are all stay within in isolation of each other. Um, one other nice thing about this whole platform is that they have the Astro CLI, the command line interface, um, which allows you to test everything locally because everything's Dockerized, right? You can really replicate the exact same workflows that you'll see in your cloud system locally, right? And so if confidently you can confidently say that it works on my machine, and so it should work in Airflow, right? The only exceptions to that, of course, are permissions, which will still cause problems, right? If you don't have access to a particular asset that you're trying to retrieve, that will cause issues in the cloud. But other than that, if the DAGs that you have created, if the workflows that you have created are working successfully locally, you can be pretty much assured that they will work in the cloud as well, which is great and really speeds up development time. The other thing that the sort of command line interface allows you to do is automate your CI/CD, right? So this entire process can be managed using any of these tools below. So we're using GitHub and GitHub Actions, but you could also do it with DevOps, Azure DevOps, GitLab, or Jenkins, or any of the other many CI/CD platforms out there. And it also allows you to monitor all of these deployments and monitor them separately, right? So you're seeing how many DAGs are successful, what are the latencies, all of those performance metrics on a deployment by deployment basis, which is a nice feature. Cool. And then performance, which I mentioned a little bit. So the big thing here is that it enables auto scaling. It has both the Celery executor and Kubernetes enabled as part of Astronomer. I really want to bring that up because the competitors, so Google and Amazon, only have the Celery executor, so they don't have that auto scaling capability. You can also deploy your workflows across multiple clusters, right, and really take advantage of the benefits that having a full Kubernetes set gives you. Questions on this? I have a couple more slides to dive a little more deeply, but at a high level, does this make sense?
Yes, it's very good. I have a question about auto scaling.
Yeah.
What does it mean? How it knows that it needs to add nodes? And also, does it look at the memory and CPU usage? Is this factors how the decision is made?
So I'm not entirely sure on that one. I'm pretty sure it's built into that monitoring as well. So seeing that if your jobs are taking too long, right, it'll spin up additional workers, or if a worker has been caught in a particular process, it'll spin something up. But I think the actual scaling process is going to be based on your CPU and memory usage. But I'll have to confirm that one.
Thank you.
So a couple things, right, on how you can tune this performance. So a Celery executor, right, is going to have a certain number of workers available to it, and then it will take the tasks that you've provided, right, the tasks that it's set to run, and it'll distribute those among the workers that it has. Um, there is a parameter which you can turn on, which you can tune on the worker concurrency, right? So how many of those can be running at the same time, and how many tasks can be running at the same time as well. So it's a little more limited, right? If you go the Celery executor path versus the Kubernetes executor, right, which has all of the benefits of Kubernetes, where you have all of these pods where every task is run in its own pod, which can scale, and so you can attribute resources depending on the actual size of the task, versus trying to accelerate workers where you need to just throw additional workers at it. And then there's also a tunable number of pods that are created per scheduler, right? So just really how big do you want the job to start as, and how quickly will it scale? Cool. Some of the other parameters that you can tune, there's really three levels of this. So when you've deployed, right, you have the deployment or environment level here, where you can tune things like how many jobs am I running in parallel, how many uh, how many tasks a single DAG can run in parallel, any timeouts, how often you refresh your code, right? So one of the nice things about the Astronomer thing and the automated CI/CD is you can have automatically generated DAGs, right? That don't need any sort of user input. And so one of the parameters that you will tune is how often do you look for a new DAG, right? How often are you expecting a automated change to your workflows? And then how often are jobs kicked off, right, is another parameter. At the DAG level, right, you can say how many runs do I have active at any given time. Typically, you'd limit that to one, but if you wanted to say I'm running a couple different tasks of the exact same DAG at the same time, you can. How many tasks are available at the same time, and then again, concurrency of those tasks. And then at the individual task level, similar, right? How many tasks can you be running at the same time? And then what's the pool of available workers that you can run per task?
Makani, can I ask you a couple questions here?
Yeah.
So first question, you mentioned Celery and Kubernetes. If we have Kubernetes, maybe we always should use Kubernetes and forget Celery. Like, what's the
Yes.
best
Yeah.
practice?
Pretty much. Pretty much. I would recommend that. Celery it's cheaper, right? And it requires well, I think that's really it, right? The overhead's going to be about the same if you go with Astronomer. So it's just a matter of having the additional, workers that you're spending on there. So if you have very simple implementations that don't require that auto scaling, right, you can get some cost savings by going with the Celery route.
Okay, and another question, you said that there are some DAGs which are generated automatically. What do you mean by that?
Yes. So because the DAGs are well, they're basically just Python code. As part of your CI/CD, you can have an automatic generation of DAGs. So one example of how you could do this, and this is how we're actually thinking about leveraging Astronomer for this, is when you create a new customer, right, as a SaaS product, right, you onboard a new customer, um, rather than having some sort of manual creation of their DAG, you're just saying, okay, add a new customer and then automatically use a templated DAG to fill in with that customer's ID. Maybe they have a particular set of integrations which you need to add, right? A particular set of steps that needed to be added into the DAG at the beginning, right? Maybe they used NetSuite and not Salesforce, or maybe they use Salesforce and not NetSuite. So taking those particular components of a DAG and putting them together into an automatically generated Python script, which you can then immediately deploy completely automatically to the Astronomer instance and not have to have a user, touch a DAG at all when you have a new customer,
This is beautiful.
right? Isn't
Yeah,
that's amazing, right? And it's going to be huge for, I think, our business, and I think a lot of businesses can really leverage something like that, where it's very hands off if you get the system set up properly.
right, thank you.
Mhm. One. So one other nice thing is you do have some pretty in-depth monitoring. So the out of the box is using StatsD and Prometheus, right? StatsD creates the metrics around how long are things taking and all of that good stuff. Prometheus then sort of interprets that and puts it into a Grafana dashboard where you can look at all of your, for a particular deployment, right? What's going on, right? Are things taking too long? How many, if you're running into concurrency issues, if you're hitting your maxes and you need to maybe scale something up manually, right? If you're not going with the Kubernetes route, all that sort of available in a nice dashboard that you get out of the box. And again, this is just one of those things where it's it takes a lot of development work, right? It takes a lot of DevOps work to put together this monitoring on a self-hosted platform. So just super nice to see it out of the box. I want to talk a little bit more about the Astro CLI, right, and how that enables some of this stuff. So I mean, it's a command line interface, right? And we all know and love them. But what it allows you to do is just kick off a Astronomer process or an Airflow process that looks like exactly like it would in Astronomer with these 3 Docker containers, right? So it uses Postgres instead of SQLite, and then it has the web server, and then the scheduler and the executor are sort of combined into a single piece. And that's all spun up locally, and you can then deploy that directly into uh, your Astronomer instance, right? Without having to sort of rebuild even your Docker container, because if it's built locally, it will sort of match with the Astronomer requirements. You can also use that to sort of automate that whole deployment, right? So you can authenticate with your system using the CLI. You can, spin up, spin down environments, and then do that auto deploy step. Cool. You can also, one thing I don't have on here, but I do want to mention, is you can check into your metrics, right? Or if things are performant or not. That's accessible using the CLI as well. Okay, so that really gets us through all of the meat of Astronomer itself. Do you have any questions before we talk a little bit about the competition? Cool. So the competition, right? And I've been sort of reiterating a few of these a couple times, but I want to just take a second to really talk about where each of these lie, right? So self-hosted, Airflow is great for very, very simple projects. If you spin it up locally, right, you can get going pretty quickly, but you very, very quickly hit sort of these roadblocks of things not being able to scale for a production environment. So if you want to overcome those hurdles, right, you need quite a bit of operations bandwidth to build out the systems to enable security, to enable logging, to enable all the stuff we've been talking about that comes with Astronomer. Now, there are two other hosted solutions which do enable you to do a lot of this stuff. So Google and Amazon both have their own with slightly different quirks, but at their core, right, they're a very simple deployment. So a nice thing here is that I don't know, computer may die. They are very simple, right? So if you want to get up and running very quickly and be able to scale, those are good options. But they do have limitations, right? So first of all, they're celery only. They don't allow you to use Kubernetes, which that's really a deal breaker in a lot of cases. You don't have access to the containers themselves, right? So you can't go in and see what's happening with your Docker container like you can with Astronomer. Um, and then the the Google option doesn't have any auto scaling. Amazon has implemented some sort of auto scaling using, I believe they just monitor CPU usage and then increase the number of celery workers, but that's sort of outside of the scope of the normal Airflow implementation. And then the other thing that I brought up before, but I want to mention again here is just that um, these options are always going to be behind the latest and greatest in Airflow just because they don't have the same depth of work with it, right? These are products from the big ones, from the big companies, and not from the folks who are really focused on Airflow.
Makani,
Cool.
I have a
So I'm gonna
question.
yes, go ahead.
Sorry.
I'm gonna
Can
move.
you return to the previous slide, please?
Yes.
So when you say Google, I think it's called Google Composer, right?
Yes, Google Cloud Compose.
Compose, right?
Yeah.
And AWS MWAA, what is that?
Managed workflows for Apache Airflow.
Oh,
I'll
okay,
actually type these out before I save these slides. It's a little bit clearer. I do have links also in the resources.
right. There is a new product from Amazon, not Amazon, Azure Cloud, called Azure Airflow. It's in private preview now. So I don't know. And this
Oh,
all products which you
I have
listed
not checked
here,
that one out.
right?
Mhm.
It's all Apache Airflow. It's just managed solution. Okay.
Yes.
And I believe Astronomer itself, it exists on all three clouds, as you mentioned, right?
Yes. Yeah. They have
Okay.
deployments across all three.
So okay. So it's no brainer. Doesn't matter on which
Yes.
cloud you are, just use Astronomer.
Exactly. Now, I will say it does take more work to spin up. Right, you do need to have someone sort of manage the roles, assign the instance to build it on top of and all that. Whereas Google and Amazon let you just sort of go in and say, I want to start a new instance, and ta-da, you're there. But it does have all of these limitations and not the flexibility that you get. So if you want something super quick that will scale and you're not expecting any, complexity ever, Google and Amazon can be good solutions for that. But if you want to have any sort of flexibility, right, it's much nicer to just go with Astronomer.
Good, thank you.
Cool. Any other questions? If not, I can dive into a short sort of a demo that I've put together. Not really a demo, but just a walkthrough of some screenshots. Cool. So let's walk through this. I just want to show off sort of what the platform itself looks like and what you can get out of it. So first of all is just sort of the main landing page, right, where you can manage multiple workspaces, even within, your same login, right? So these are all going to require uh, a separate user, right? So these are completely separate IAM users. These are going to be completely separate Airflow instances, right? So we only have the one. We only needed the one. And then if you dive into that, or sorry, I'm going to, before we dive into that one particular instance, we can show all of our clusters, right? So you can have an instance with multiple clusters. But again, we only have the one. Ours is a pretty simple implementation currently. This is one of those nice dashboards that you can see just at a high level, right? Do I have, what are my successful task runs? I believe this is, yeah, so this breaks it down by deployment. So where are all of your runs happening? And so if there's something that sort of stands out to you here, right, you can dive in. Why are we not having successful runs in prod, right, all of a sudden? And you can dig into those issues. So then once you've dived in, so up here in the top left, you'll see I've gone into my one Veretto instance, and here we have 3 deployments. So we have a release, a staging, and a prod environment. And so we just promote from staging to release, and then from release to prod. And this allows us to do that, in a sequential manner. Right up here in the top right, there's a deployment button, which, so super easy to just create a new deployment. You give it a name and it's off and running. So then you can interact with it via the CLI and add new deployments. Okay, so this view breaks down all of your DAGs, right, and shows you when have they been successful, when not, right? So I'm looking at this and saying, okay, this one's probably new, right? This one had some issue here, and this one clearly has had some problems recently, right? So you can quickly identify that with some of these dashboards that they have. You also have logs, right, on the scheduler itself, right? So there's a couple different levels of logging, right? You can say, do I have did a DAG itself fail? And then within each one of those steps, right? In Airflow, you can see what are the log outputs and where were the failures. This will surface those highest level logs of which DAGs failed and how and when and why. Alrighty, so this takes us back to the staging deployment, right? And so here you see some additional information around what's the deployment, when am I hitting, my 77% of the CPUs, when am I hitting worker memory limits, how many DAGs are successful, failing, all that good stuff. So just a very small high-level overview of your deployment and what's going on with it. This is just Airflows, right? So if I go back, once you click Open Airflow, that takes you into this page, which is just your standard Airflow implementation. So you've got all the usuals, your DAGs, your individual rerunning of steps, your kicking off of new steps, and then clicking into the logs as you would with any other Airflow instance. It also lets you look at at a high level, all of the DAGs that you have, which are the ones which are enabled, which are the ones that are not, and then, successful runs, not successful, and modifying your schedules, all that good stuff. That is just, sort of standard Airflow workflows. And really, so this is the nice thing about Astronomer is that it lets you and your data engineers really live in these 2 screens, looking at these at a high level and not having to really worry about all of your permissions and setting up your logging, setting up your management stuff, right? That's all coming out of the box. And that is all I have for you all today. So there's some resources here on, the history of Airflow, the history of Astronomer, and then some of the other options and some other just helpful articles. But that's all I got for you all today. So thank you all for listening.
Wow, thank you.
Awesome.
Makani. Yeah, this was very good, and we're just on time. Guys, please ask questions. It's a
Yes.
rare opportunity to
Fire
talk to
away.
Makani.
So yeah, thanks first of all, Makani. That was pretty amazing. I was just wondering, so how long have you been working with Astronomer and Airflow now in particular? And what do you think are some of the downsides of it? So what are things you would say, oh, I wish they would add this, or they would improve this, or they would change this?
Yeah, for sure. So I have been working with Astronomer for as long as I've been working with Airflow. I started with Astronomer and then tried out some of the other versions just to test and went back to Astronomer. That was actually, so we began this implementation late last year. I think October was when we sort of got everything kicked off and started the implementation. So been working with it since then, and it's just a very nice tool to have. I've gotten used to using, just shell scripts and orchestrating with cron, which really works, right? But it takes work. And this just sort of smooths everything out. The the downsides for sure, I think there's a lot of there's a steep learning curve to it, right? So it has a nice dashboard for you to see things at a high level, but if you really want to dig in, right, I was saying you can access the Dockers themselves, you can dive into the deployments, but it's not a simple process, right? So you have to read through their documentation. Their documentation is quite good though. So as complex of a system as it can be, it's documented pretty well, and the folks there are pretty helpful if you need to reach out and you're, a client of theirs. Some of the other sort of issues are, I think it all sort of goes back to the simplicity of it, right? It's not a super simple project. It takes a lot of the work away from you and really manages it, but it's not as user friendly as like the Google Cloud or the Amazon version, which is really just a couple button clicks and you're off and running, right? So I think if they could simplify, that would be good if they could offer maybe some simplification. But the problem with that is once you simplify, right, you take away some of these, additional abilities that you have with a more complex system. So, all about those trade-offs. Um, yeah, that's probably the big thing is I wouldn't recommend it for anyone who's not expecting a relatively complex system, right? If you're doing something simple, if you're doing something, minimal and you're not expecting to need to really scale, at least in the near future, the Google and Amazon are very quick to just set up or just a local proof of concept with Airflow.
Okay, that's helpful. Thank you.
This is a very nice presentation, man. You mentioned how you like working at startups. Is this your first one, or you've been through a
This is my
few?
first one.
Oh, yeah?
No, this is my first one. So I previously was working at National Debt Relief, so doing finance and a pretty standard sort of company, and took the opportunity to jump into the startup world, and it's phenomenal. I was the third person at the company, and so that's a very interesting place to be, where you have so much input and direction into everything versus, a big 2,000 person company where, the president says what he wants and that's how things go, right?
Yeah.